Download this code from codegive.com, link in the description below. OK, let's dive into the world of JAX London 2012, Java, and the infamous machine, which, as you'll see, refers to a specific presentation by Goetz. I'll break this down into digestible parts, provide context, code examples, and explanations to give you a comprehensive understanding. Part 1, Setting the Stage, JAX London 2012 and Goetz. JAX London JAX London is a prominent annual conference focused on Java, JVM languages, and related technologies. It's a place where leading developers, architects, and industry experts gather to share knowledge, best practices, and emerging trends. JAX conferences also happen in other cities such as JAX DevOps in London. Brian Goetz Brian Goetz is a highly respected figure in the Java world. He is the Java language architect at Oracle, formerly at Sun Microsystems. He is known for his expertise in concurrency, performance, and language design. He was instrumental in the development of features like concurrency utilities, java.util.concurrent, and lambda expressions in Java. He co-authored the widely acclaimed book Java Concurrency in Practice. Part 2, The Machine, Brian Goetz's presentation. The machine you're likely referring to is Brian Goetz's presentation at JAX London 2012 titled Going Native with Java. The presentation explores how Java code can be compiled to native code for potentially significant performance improvements. The core idea is to leverage ahead-of-time (AOD) compilation to create optimized, platform-specific executables from Java applications. Why is this important? Traditional Java Java traditionally relies on the Java Virtual Machine, JVM. The JVM is a virtualized environment that interprets bytecode. While the JVM offers portability and memory management, it introduces overhead, particularly in startup time and potentially in runtime execution. AOD compilation translates Java bytecode into native machine code before the application is run. This eliminates the need for the JVM's interpreter or just-in-time (JIT) compiler at runtime, leading to faster startup times, potentially better peak performance, especially for long-running applications, reduced memory footprint, no need to load the JVM, improved predictability, less warm-up time. Key technologies mentioned / implied GraalVM Although GraalVM wasn't explicitly the centerpiece of the 2012 presentation, the ideas presented laid the groundwork for technologies like GraalVM, which provide sophisticated AOD compilation capabilities for Java and other languages. GCJ, GNU compiler for Java. GCJ was mentioned during this period as a possible route. GCJ has limitations, and is no longer actively maintained, but it was one of the earliest mainstream approaches. Part 3, Key concepts and technologies involved. 1. Ahead of time, AOD, compilation *. The core concept. It contrasts with just-in-time, JIT, compilation, where code is compiled during runtime. 2. Native image *. A native image is an executable file that contains the application code, necessary libraries, and a minimal runtime environment required to execute the application. It doesn't require a full JVM to be installed. 3. GraalVM, a more modern approach. GraalVM is a high-performance polyglot VM that supports AOD compilation for Java and other languages. It uses a sophisticated compiler infrastructure to produce optimized native images. GraalVM has become the primary tool for achieving the goals Brian Goetz outlined in his presentation. 4. Closed world assumption *. AOD compilation often relies on a closed world assumption. This means that the compiler needs to know all the classes, methods, and dependencies that the application will use at compile time. Dynamic class loading or reflection can pose challenges to AOD compilation if the compiler cannot determine the necessary code at compile time. This requires configuration to hint to the compiler about reflection use. 5. Static analysis ** AOD compilers use static analysis techniques to determine the code that needs to be included in the native image. This involves analyzing the application's bytecode to identify reachable methods, classes, and dependencies. 6. Reachability analysis * determining which parts of your code are reachable during execution is crucial for AOD compilation. The compiler tries to figure out what methods will actually be called. Unreachable code is excluded from the native image to reduce its size and improve performance. Part 4. Code examples, using graalvm. Let's illustrate how to create a native image using graalvm. This is a modern take on the ideas goetz presented. Note that this requires you to have graalvm installed and configured. Follow the graalvm documentation for installation, example using daemon or downloading from the graalvm website. Crucially, install the native image component of graalvm. Example 1, a simple Java application. Steps to create a native image *. 1. Compile the Java code *. 2. Create a jar file, optional, but recommended for larger projects. 3. Generate a native image, using native image. The native image command compiles the Java bytecode into a native executable. It performs static analysis and reachability analysis to determine the code that needs to be included in the native image. 4. Run the native image *. You should see hello, native world, printed to the console. Notice that this executes without needing the Java command. Example 2, dealing with reflection. Reflection can be tricky with AOD compilation. graalvm requires you to provide configuration files that tell it about classes and methods that are accessed using reflection. Steps *. 1. Compile *. 2. Generate reflection configuration, using the native image agent. This is a crucial step. graalvm provides an agent that can run your application and automatically generate the reflection configuration. This will run the Java application. The agent will observe the reflection calls and create configuration files in the config directory. Important configuration files will be reflect-config.json. 3. Create the native image, referencing the reflection configuration. *-enable URL protocols is included if you might be using URLs in your application. *h reflection configuration files, specifies the path to the reflection configuration file. Multiple configuration files can be specified, separated by commas. 4. Run the native image *. You should see the output, my class says, hello from reflection. Explanation of reflection configuration *. The reflect-config.json file will contain entries like this. This tells graalvm that for the class my class, all declared constructors, public methods, and declared fields should be accessible via reflection. For java.lang.string, the method value of with a parameter of type java.lang.object should be accessible. Part 5, Potential Issues and Considerations. Configuration overhead. Configuring AOD compilation, especially when reflection or dynamic class loading is involved, can be complex and time-consuming. The automatic agent helps, but you might still need to tweak the configuration manually. Limited dynamic capabilities. AOD compilation works best when the application's behavior is relatively static. Highly dynamic applications with extensive reflection or dynamic class loading might be challenging to compile to native images. Third-party libraries. Not all third-party libraries are fully compatible with AOD compilation. Some libraries might rely on dynamic features that require special configuration or modifications. Build time. AOD compilation can take significantly longer than traditional Java compilation. Debugging. Debugging native images can be more difficult than debugging Java code running on the JVM. Part 6, Benefits of using native images. Faster startup time. Native images eliminate the JVM's warm-up time, resulting in near instantaneous startup. This is crucial for serverless functions, command line tools, and other applications where startup latency is critical. Reduced memory footprint. Native images have a smaller memory footprint compared to applications running on the JVM. This is beneficial for resource-constrained environments like embedded systems or cloud-native applications. Improved performance. Native images can achieve better peak performance compared to Java code running on the JVM, especially for long-running applications. The AOD compiler can perform more aggressive optimizations than the JIT compiler. Security. Native images can improve security by reducing the attack surface. The absence of the JVM eliminates certain classes of vulnerabilities. Deployment. Native images are self-contained executables that can be easily deployed without requiring a JVM to be installed on the target machine. Part 7, Conclusion. Brian Goetz's 2012 JAX London presentation highlighted the potential benefits of AOD compilation for Java. While the technology wasn't as mature then as it is now, the ideas he presented have paved the way for tools like graalvm, which enable developers to create high-performance, low-footprint native images from Java applications. AOD compilation is not a silver bullet, and it's important to carefully evaluate the trade-offs before adopting it. However, for applications where startup time, memory footprint, and peak performance are critical, AOD compilation with graalvm can be a powerful technique. Remember to consult the official graalvm documentation for the most up-to-date information and instructions on using native images. Good luck exploring the world of AOD compilation.